Let's talk about what gradient means and how we can measure it. So gradient is the same as slope. So we're just talking here about how much the elevation is changing over a given distance. So if we look at this example here, we can say some things about this map, right? It's a map that has index contours every 100 feet. Here's the 100-foot contour, which is darker, and the 200-foot contour, which is darker. And it has a contour interval of 20 feet. So we're at 100, 120, 140, 160, 180, 200, going up in this direction here. So we can actually not only see what the gradient looks like, and it looks like it's fairly steep, at least compared to maybe an area on the map over here, where the contours are more widely spaced, or an area here where there's no change in contour. We can see that we're crossing several contours within a relatively short area here. But we can go beyond that, and we can actually measure what the angle of the slope is between A and B. And in order to do that, we will use a function called tangent. So if we want to find out what this angle is, which is what the slope of the land would be, right? Flat would be 0, and here we're at some angle, which is called theta. We can say that the tangent of theta is equal to the rise, which is the opposite side over here, and the rise is going to be the difference in elevation. This is what we're going to get from the contours. The run, which is what's going to be, we're going to divide by, is the difference in distance between these 2 points on the map. The map is a flat surface, so it's looking just like this here, and we're going to be able to see that difference in distance here. The way that we're going to do that is we're going to use our contours to get the rise. We're going to figure out what the elevation is here and subtract them. And then in order to get the run, we're going to measure that distance using the scale that's provided for this map. My next slide here, where we're showing, first of all, we're interpolating the value that we would have at B for elevation and the value at A. So A is about halfway between the 180-foot contour and the 200-foot contour, so we'll call that 190. And the B is between the 100-foot contour and the 120-foot contour, but it's more close to the 100, so we're going to call that 105. To measure the distance from A to B, that would be, so the difference between these two would be 190 minus 105 gives us this 85 here. And then to measure the distance, I'm going to go out of full screen for a second here. We'll just grab our scale here, twist it around, and then lay it so one end is at A, and the other end here is about a distance of 630. So that's going to be the run. The distance from A to B is going to be 630 feet. So the equation that we'll set up is the tangent of this unknown angle theta equals the rise divided by the run, which is going to equal 85 feet divided by 630 feet, which is going to be the same as the inverse tangent. So if we do that division and then we take the inverse tangent, that's how we're going to get this angle of slope. And let me just show you in case you're not familiar. Once again, going out of full screen. Open up my calculator here for a second. If we have 85 divided by 630, that's what this is equal to. Now, I don't want to take the tangent of this number. I want to take the inverse tangent, or the tan to the minus 1 of this number. So on the scientific calculator, I'm on the scientific one here. What I would do is do the second function until I see a tan to the minus 1. I take the tan to the minus 1 of that value, and that's how I get 7.68 degrees, or rounding to 7.7 degrees here.